All right. So the law of sines is our topic. Up until this point, it's important for you to recognize that every triangle we've worked with has been a right triangle. And so the question is, well, what if you want to solve a triangle that's not a right triangle? How do we do that, right? And so we're going to start talking about that today and on Monday. Today we'll talk about the law of sines. Monday we'll talk about the law of cosines. So I'm just going to give you the law of sines first, and then I'm going to kind of explain where it comes from. Before I do that, some key things for notation. When we're working with triangles, and we're talking about angles that we don't know, we're going to use capital letters. So notice here we have a capital letter A, so that'd be angle capital A. And across from that angle, we're going to use a lowercase letter, and we're going to use the same letter. So we got angle A, and side A is across or opposite angle A. We have angle B here, which is capital, and across from angle B, we have a lowercase b to represent that side length. Okay. So there's this relationship between this. So if you take the sine of that angle divided by the side across from it, so the sine of A over side length A, that's proportional to the sine of any other angle in the triangle over its opposite side, so sine of B over B. Okay, and that's the law of sines. You can also extend that proportion to use C. You could say this; it's also equal to the sine of C over side C. Okay, but I'm just going to focus in on the first two because these are ambiguous. It doesn't matter which side length or which angle you're using. So where does this come from? Well, if I draw a triangle and let's say it's not a right triangle, it doesn't, any kind of triangle that we're working with, and let's say this is angle A here and this is angle B. So this would be side A and this would be side B. And I want to show you that the sine of A over A is equal to the sine of B over B. Well, what is the sine? It's a side length of what? So the sine of A, for example, the sine of A is what? It's the side length of what kind of triangle? A right triangle. So you need a right triangle with the same angle, and it's got to be a right triangle. And what else has to be true about that right triangle? Has a hypotenuse of 1. And then so then the opposite side length is the sine of A. That's what the sine of A is. Okay? So I'm going to draw a picture. That picture represents the sine of A. I'm also going to draw a picture representing the sine of B. The sine of B, you have this right triangle here with a hypotenuse of 1, and this length is the sine of B. Okay? Well, in this triangle, I could drop an altitude. Remember, an altitude goes through your vertex, it's attached to your vertex, and it's perpendicular to the base. And so then it splits it into two right triangles. And the right triangle on the left side is similar to my right triangle over here, right? So I could set up a proportion. Let's call this height x. And I could say, well, b over x is 1 over sine of A. And then I could do something with the right side as well. I could say A over x is 1 over sine of B. And I'm going to, in each of these, I'll cross multiply, and I'll get x is B times the sine of A on the left side. And on the right side, I'll get x is A times the sine of B. Now, I really don't want x, and I want to connect these two together, and they're both equal to x. So the next natural thing to do is just use substitution and say, well, because they're both equal to x, we can set them equal to each other. Okay, remember my goal here is to get to sine of A over A equals sine of B over B. Almost there. I got one more step. Maybe tell me what my last step is? Divide, yes, by. I need it, one step I need to get here. Divide by what? AB. I divide by AB, B is reduced here, A is reduced here, and we have it. Okay. So that's where it comes from. That's, and we could do something similar for C. And you could do this with any triangle, but instead of having to go through all this each time, we can just say, okay, memorize the law of sines, which is pretty easy to memorize, that sine of A over A equals sine of B over B, sine of C over C, and just use that. And so let's see how it's used. So number one, we have a triangle. Is it a right triangle? How do you know? What's that? Okay, so you can find your missing angle. Is it 84? I think it's set. Try it again. 74. Okay, so you get 74 here. All right. So which side is the hypotenuse? The answer is there is no hypotenuse here because it's not a right triangle, right? Hypotenuses are hypoteni. I don't know. They're unique to right triangles, though. So there is none. But we can use the law of sines, which says, hey, if you find an angle, the sine of that angle divided by the side that's opposite it. So sine of 35 divided by 12. It's proportional to the sine of another angle divided by its opposite side length. So sine of 71 over x. And once you get that, I mean, it's super quick to write that. It's quicker than what we've been doing before. Because before we had to write another triangle that it's similar to, and this is even less work. So then you cross multiply. X times the sine of 35 is 12 times the sine of 71. And then what do I do next? Divide by what? I want x by itself, so I divide by the sine of 35. So x is 12 times the sine of 71 divided by the sine of 35. All right, now let's talk about reducing that fraction. What can we do to reduce that fraction? Can I cancel out the signs? There's a sign here and a sign here. Can I just do that? Are you sure? Good. You cannot do that because the sine of 71 is a side length of a triangle with angle 71. That's what that means. And this is a side length of a right triangle with an angle of 35 degrees, right? You cannot separate these. If this was a 70 and this was a 35, could I reduce those numbers? No. Don't touch this part, okay? Just leave it alone. Okay, don't try to reduce that. All right. Now, this lesson, mathematically, it's going to seem easier, but typing it into the calculator is going to get harder. And so hopefully you brought your calculator with you to practice this. So let's make sure we're entering these things into the calculator the correct way. So there's two different types of calculators here. Okay, so there's a calculator that you can see what you're entering in. If you can see what you're entering in, it's not right. This one's not going to feel too bad for you. You should get 19.8. Now, if you can't see what you're typing in, and you know who I'm talking to, okay, because you're like, yeah, when I hit sign, I don't see sign show up on the screen, and you kind of working backwards, it's gonna get worse than this. And so here's what I suggest you do. I mean, until you get to pro status. Now, if pro status, you could type all that in and know what you're doing and get that answer. But if you're not getting that answer, here's what I suggest. I type in 71 sign, get that, then type 12, and find what the numerator is. You'll get a decimal, and then write that decimal out. And then clear it, find sign 35, sign of that, get another decimal, and then type the decimals in, and then you should get 19.8. It's a little extra work, but until you get to pro status on that calculator, and you want to make sure you're getting the right answer, okay? All right, try number 2. Let's see if you can get it right. All right, so this is just like number 1. So you can say sine of 18 over 5 equals sine of 114 over x. Cross multiply, you get x times the sine of 18 is 5 times the sine of 114. Divide by sine of 18. And then enter that into your calculator. You should be getting 14.8. Rounded to the nearest 10. Okay. Questions? Okay. Here's what I want you to do. Check your work. If you had less work than this, then you're probably not showing adequate work. Because I don't like to show extra work. This is like the minimum that like I'm showing every critical step that needs to be shown here. So if you're not showing that much work, then make sure you're showing at least this. Okay. If you're showing more than that, that's fine. But this is your bare minimum right here. Okay. That's needed. All right. Skip 3. Try 4. Was 4 different? Not really, but if you're stuck, can somebody give a hint? You gotta find why. Where's the why? Where would you put why? What do you mean by why? No. What's a hint, guys? Find the missing angle. If you haven't done that, then you're on the wrong track. Okay, you gotta find that missing angle to do this. Yeah, we're skip 3 on 4. Okay, so what is that missing angle? So you're going to go 180 degrees, subtract the 96, subtract the 53, and then find out what's left, and you get what? 41? 31? 13? Uh-oh. We're just looking for the missing angle. So 31? Okay, we agree on 31. All right, so then we can say sine of 31 over x is equal to sine of 96 over 27. Cross multiply, you get x times sine of 96 degrees is 27 times the sine of 31 degrees. And then divide the 27 times the sine of 31 by the sine of 96. And then you use your calculator, and what do you get about? 14.0. Okay. All right. Then number 5 and 6 start the same, but then it gets uglier for your calculator. And I'll show you why. I'll do 5 with you, and then I'll let you try 6 on your own. So 5, we're going to use a lot of signs. So sine of x over 21 is equal to sine of 61 over 24. God bless you. All right, what would you do after that? Cross multiply, so 24 times the sine of x is equal to 21 times the sine of 61. All right, what would you do after that? Divide what? Divide by sine. You have to have an angle when you say sine. Sine of what? Actually want sine of x by itself. So I want to get rid of 24. So divide by 24. So the sine of x equals 21 times the sine of 61 degrees over 24. All right. Don't use your calculator yet. We want to get x by itself first. So what's my next step? Can't divide by sine. Use the inverse. So you write x equals the inverse sine. And then I'm going to use brackets. You could use big parentheses or brackets, doesn't matter. 21 sine 61 degrees over 24. That's what you got to enter into your calculator. All right. Go for it. Let's see if you can do it. So if you could see what you're typing, it's up to you. But if you could see what you're typing, you can type the whole thing in. If you can't see what you're typing, you're not going to want to try to type that whole thing in. You're going to break it up. Okay. I haven't finished yet. Let me finish, and we can compare. All right. What do we think it is? If we round to the nearest tenth, 49.9 degrees. Okay. So guys, if you can see what you're typing in, this is what it's going to look like. You're going to type in inverse sine, and then your calculator gives you a parenthesis, and then you're going to type in 21. You could type in sine, or you could do times, doesn't matter. Sine, and then your calculator gives you another parenthesis. You're going to type in 61, It's important that you close the parenthesis there, otherwise it's going to mess you up. And then you're going to hit divide 24, and then you're going to close it, and you're going to hit enter, and it should work for you. That's if you can see what you're typing in. If you can't see what you're typing in, then you want to break it up into smaller pieces, okay? If you successfully got 49.9, go try number 6. If you didn't get it, stay on it until you get it and ask for help. Ask me for help. Okay. All right, so number 6, here it is. If you got it right, 80.4 degrees.